In the 10th question, we have if the sum of first p terms of an AP is equal to the sum of first q terms, then find the sum of first p plus q terms. Okay. Given sum of first p terms is equal to sum of first q terms of an AP, this sum of 2 find S of p plus q question mark, that is required, right? Okay, let's talk about the solution. So let AP is A plus D, A plus 2D, comma dot dot dot. This is what we have. Since SP equals P by 2, 2A plus P minus 1 D. This is what you have. SP. And what is SQ? This is Q by 2, 2A plus Q minus 1 D. This is what you have. SP and SQ are given, right? And what do we need? S of P plus Q. And what is that? This is P plus Q by 2, 2A plus P plus Q minus 1 times D. So if you observe carefully, we need the values of A and D both. Okay, this and this are given equal. So at max what we can do is we can find a relation between A and D. Yes. Let's try to find a relation between A and D somehow. Let's see. So how will we find that? We have 1 and we have 2. There are 2 equations. We can simply subtract these two. 1 minus 2. And that tells me, okay, SP and SQ, they're equal. So the left hand side becomes 0. What about the right hand side? In the right hand side, I have P by 2 into 2A, which is PA, Q by 2 into 2A, which is QA. So for A, I'll have PA minus QA. I can take out a common and this is what you'll get. Yes. What about for D? I have P by 2 times P minus 1 times D, Q by 2 times Q minus 1 times D. I can take out a D by 2 common from here, and in the bracket what you'll get is P times P minus 1, which is P square minus P, Q times Q minus 1, which is Q square minus Q. This is what you'll be interested in. Okay, A or 0 is equal to A times P minus Q plus D by 2, and we observe that P square minus Q, I can write it as P square minus Q square minus P plus Q in this manner. Yes. This can be factorized at P plus Q, P minus Q, and I can take out a minus common, P minus Q will remain. So P minus Q from here, P minus Q from here, and P minus Q from here can be brought out common. Yes. Okay, and can I take out a 2 also common from here, from the denominator? What is remaining over here is 2A. D times what will remain over here is, please observe, P plus Q will come from here and there will be a minus 1 over here. This is what I am getting. This whole expression is equal to 0. Yes. Okay. Now do you see the answer? Very close. Yes. Sum of first P terms of an AP is equal to sum of first Q terms. The person should have mentioned, although the person should have mentioned that P is not equal to Q, but we observe that sum of P terms is equal to sum of P terms, so that will not be any condition. For here, S of P is equal to S of Q implies that P is not equal to Q. And since this is non-zero, the product of these two is 0, therefore this will be 0. 2A plus P D times P plus Q minus 1 will be 0. This is 0. And therefore S of P plus Q, what about this one? This is nothing but P plus Q by 2, 2A plus P plus Q minus 1 times common difference D, and since this bracket is 0, this overall value will also be 0. That's my required answer for this question over here, as you can clearly see. So subtracting these two was important. Once we found the value relation between A and D, things become very simple after that. That's all that you need in this 10th question.